Well, welcome to the Los Alamos Faith and Science 2024 annual meeting. We have a presentation in a little while from Chick Keller, and we will also have some voting for the 2025 board. Okay, but let me bring you up to date on what we've done this last year. And if you have any questions, just raise your hand. I'll be happy to answer them if my voice holds out. I have a little bit of a cold. Technical support, please. Ha. I love it. We have to have the young people here so that we can know what we're doing, right? Right. Okay, so this is a summary about the Los Alamos Faith and Science Forum. It was formed quite a few years back as a group of scientists, engineers, and professionals, helping people to think about science and religion and the harmony and complementarity of these two modes of being and knowing. And from about 2009, I think it was, wasn't it, Nels, that folks began to talk about how we can bring people together for the intersection of faith and science and to learn from each other what's relevant, what we still need to discuss, and what is controversial. So in the summer of 2014, we began having summer speakers, and we have invited many people from across the country to come and be our guest keynote speaker, and we've tapped into the lab as well as the community for very interesting talks throughout the summers. If you go to the website, which I'll show you in a few minutes, you can also see all the presentations, the slides, and some of the recordings over the past years if you have an interest in looking back and learning about what has gone on in the past. How's my voice? It's very sultry, right? Okay, so this evening we are going to, in a little while, hopefully, we'll have a presentation by Chick Keller. We're probably going to move that down to a lower part of the agenda. We're having trouble getting his to arrive via email. So we're working on that as we talk. We always have some technical issues, which we just love, right, Reese? We got to have faith. Okay, we have the science, but I don't always have faith in the science, right? But I have faith in my faith. Anyway, never mind. Different topic. Okay, so this is the agenda. We'll review the minutes here in a few minutes from 2023, and then I'll give you the annual report for 2024, followed by the financial report from Bob Dreiser. Oh, look at that. It worked. I'm sorry, this is being recorded, so I should probably be far more professional. Why is there a thing up here? Yes. Do you want me to? You don't know? Okay. Oh, look at this. A man of many talents. Okay. Give us a few minutes, Chick, and then we'll have you ready to go. So the minutes of the 2023 meeting were pretty much like they've been in the past. We didn't have too many strange nuances, but we did have a very good financial report, which we'll have a summary of here in a few minutes as well. We've consistently been earning a little bit of funds. We've had some very generous corporate sponsors and church sponsors, so I really appreciate that. We discussed quite a bit, a whole variety of different themes and topics for the summers, and you can see the listing of them there, I think. And some we were able to bring into this summer's presentations, and some are still possible for the upcoming, this coming summer season. We had the election of new board members, and I will cover who is on the board at this moment in a few minutes. So Chick, do you want to interrupt me now and do your presentation, or would you like to eat your pizza? You see how formal we are here, right? Okay, so the theme for the 2024 summer lecture series was elucidating the Israelites, the spiritual mind, and the universe. I'm going to skip this page. So you can see here throughout the weeks in the summer, we had a variety of different talks. I'm going to just read the titles of them, and you can read the rest on your own. We had galaxies versus people interacting with the Creator. And that was by Chick Carroll. We had the ancient Near Eastern cultural context for Israelite temple worship, which was well received and very interesting. We had the anti-Semitism. Where are you, Jack? I can't say that word. Anti-Semitism. There we go. And anti-science. A deadly overlap in the case of the missing hyphen. Maybe the case of the missing hyphen. And then we had an abundance of archaeological and historical evidence links the Exodus events to the collapse of Egypt's mighty 18th dynasty, and that was by Dr. Stephen Collins. And I think you all know that he has his university and a lot of his museum artifacts in Albuquerque. He spent 16 seasons in Jordan doing a very famous dig now, because with his efforts we were able to find the actual location of Sodom and Gomorrah. And that has been really revolutionary. And we've been the beneficiaries of some of that information and data. I just am really always thrilled when Stephen Collins joins us. And he also had the Trinitite. Who remembers when he brought the Trinitite? And we all got to look at the Trinitite, but it wasn't from New Mexico, it was from Sodom and Gomorrah. Anyway, different topic, we'll talk about that later. Just one of my favorite areas. On July 9th, we had the impact of moral values upon religion and science, and that was given to us by Kirk Lisbon. July 16th, ritual, religion, and the scaling up of society, insights from anthropology. That was by Dr. Niels Hoffman. July 23rd, we had neurology, brain mapping during various mental states, prayer, meditation, religions, and mystical experiences. And that was by Dr. Andrew Newberg. He was actually our guest speaker, and we were very privileged to have him come and join us. And it was very, very interesting sort of discussion, and we're hoping that he will have more data to share with us in the future. Some of the data was good, but I think there's more that we will learn from him. July 30th, Psychology and the Near-Death Experiences by Dr. Roy Hill, and he drew from, I think, over 1,000 different experiences that he had collected from a variety of different prisoners, as well as other. Okay. We come here, we always have technical difficulties, but we love it, right? And then on August 6th, we had knowledge and certainty. How do we come to know what we know? And how certain do we need to be of knowledge to say that something is known? And that was by Dr. John Ambrosiano. I want to thank all the folks that did the summer lecture series. It was fantastic. I hate to belabor it, but they were top notch and very well received by the audiences. So thank you. You can give them a round of applause. During the summer, during the Lenten soup supper presentations, a variety of our members and board members offered presentations. We were all at the United Church, and I think that went over really well. And we'll try to do that again this year. During April of 2024, we had a discussion group, and this year we discussed Andrew Davison's book on astrobiology and Christian doctrine. And we had a number of folks pick up various chapters of that book and presented an overview of the chapters in the book. And we had some pretty good discussions. And I will send out an email for the upcoming discussions that will be planned in late winter, I guess, would be the best guess. Okay. Just for folks that don't know, that is the website up at the top. Okay. So you can check out all the presentations and different aspects of the forum. Now I'd like to ask Bob Dranger to come and give the financial update.
I thought she was going to hold it for me. Okay, let's see what happens when you. Okay. Okay, this is stuff that'll put you to sleep. That's the big narrative here. Let's do this. Let's move forward a slide where you can just look at the income table. Okay, okay, good. Right there. Just to give you a broad view, looking back over the last couple of years, is budgetarily wise, the Faith and Science Farm has been growing. When you look at these numbers, for example, when you take a look at the whole year, you see that 9,549 below right-hand corner. That's the income for this last year. And prior years, it might have been down, say, in the $6,000 range. So financially, things have been picking up for it there. And when you take a look at the flow of money, if you look at up in January, February, at the top of the screen, you'll see it says corporate contributions by churches. You start out with $2,200 back in January and February. That's $2,200 out of about nearly $10,000. When you come on down to August, there's $3,750 by corporate contributions, and the grand total at the bottom is $6,250 out of that $9,500. So churches are a major source of financing, and I would like to say thank you to all those churches who have done that. It's a big help there. Other thing that you see in this is in blue. When you look at June, July, and August, that's when the summer programs are on. We're having that 9 weeks of presentations. That's also when people are paying for meals, contributing to the dinners, these high-class pizzas that we're eating here. So there's a big chunk of money that comes through in those 3 months of summer activity from individuals for meals. And you'll see down at the bottom about $1,900. So midsummer, lots of money coming from the summer program. And at the beginning of the year, corporations helping out. And the thought is that this coming year, it might follow the same cycle. So in January, February, I'd anticipate we'd see money coming in corporately. And then when we get to the summer, then we see more money coming from individual contributions of one type or another. Okay, now how do I make this thing go forward? Okay, the expense side of this thing. When you take a look at what has been going on, this last year, I got into doing sala for the first time. Worked there. So when you take a look at space rental, it comes down to a grand total of about $2,600. A good portion of that's going to be paying sala for the space that you're sitting in, like right now, for it there. Also, I was joking about the pizza, but we've spent about nearly $1,500 on dried ancient pizza during this last year for it there. It amazes me that pizza can add up to so much. So each time you take a bite of that pizza this evening, think that you're biting into gold, okay, for it there. And then the other thing to be aware of is when we have a speaker come in from out of the Los Alamos area, there's expenses to pay for their trip to come on over, their plane ticket, that type of thing, and also paying them something. So you'll see in July, a $2,700 honorarium being paid for a guy to come on over. And in addition, for the flight and all, another $900. So it's nice to have a speaker who may have a national or regional reputation, but also there's a cost involved for it there. When you take a look at the final totals for the year, you'll notice that we started the year with about $12,200. And then as the months went by, lo and behold, hey, how did I do that? How did it? I have no idea how I did that. It grew from about $2,300 roughly to about $13,500. We actually brought in more money than we spent for the year. And that to me suggests as we go into this new year for planning, we have funding available. And I don't really see any reason why we shouldn't be able to do as well this coming year as we've done in this year that we're just completing. Hopefully that gives you an overview. And if anybody wants to get at the data, are these actually put on the website now? So if you're suffering from insomnia, just go to the website and we guaranteed to put you to sleep, such as bookkeeping right there. Any questions or comments? Okay, here you go.
Thank you very much, our excellent treasurer. We're very, very privileged. Okay, we have now comments from our committee chair, primarily our UV and video person. This is a listing of the various committees and who heads them up and who's on them. Okay, sir. Please welcome Kirk Wiesbrod, the Vice President.
Hi, good to see you all this evening. Oh yes, I still gave a presentation and got chastised. Let's see. So basically what we're interested in is taking a look at after the experiences that we had in 2024 or so this year, as far as recording the videos and everything, whether they're options. So we kind of were looking in backup systems and what we would be using. We basically see that there's a number of different components that we require. It's basically the ability to, for the facility to project an image like you see, provide audio, good audio quality, both during the presentation and during the question and answer period. And in addition, it's good to be able to record the presentation so we can put it on the website and also Zoom the presentation in real time. At least one of the presentations last year, like 13 presenters, 13 people that were on Zoom for that presentation, which was pretty significant. So the image that we'd like to create to be saved is basically a video image of the speaker superimposed on slides provided by the presenter and have good audio, typically with a lapel mic possibly. So you wouldn't have to hold two mics if, anyway. And then the question and answer session, we'd have an image of the audience, like you'll see here in a bit, as well as the speaker. And also the audio will include a second microphone that circulates through the audience. And this again would be a small mic that would be attached to a regular stick mic. Okay. So we looked also at different places where we could have a meeting. Basically, the rooms here are quite good, and they were very good over in the Roxy room this year. And also, other options are to have it in one of the halls in one of the churches. And for this, for like Kelly Hall over at the Episcopal Church, you'd probably have to invest $1,000 to $2,000 for a sound system that would be comparable to Sala, let's say. Another possibility is to have PAC 8 videotape the presentations. And that was another cost that we were looked at and had in the past. But the downside of that is we'd still have to provide Zoom some way. So basically, we're looking at a backup system for recording Zoom and independent video and sound if it appears that it continues to be needed. And also, we're looking at the capability of having a presenter that's not on site give a presentation through Zoom or whatever to us, and then we can ask questions and answers back. So it might be possible to get people from all over the country or the world to give presentations and not have the expense that's often involved with having a keynote speaker. Anyway, so that's it.
Do you have any questions for Kirk at this point? You can find him. He won't be far. Thank you very much. Okay. Okay, we're going to, these are our current board members. We're going to have a presentation by Chick. At the same time, we're going to be doing voting. So if you bear with me for just a couple of more slides, we'll turn it over to Chick. So this is the listing currently, okay? We've had a couple of members step down. All right, so this is a little complicated. You ready? This is your science degree. You ready? Who does math? Anybody? Okay. Okay. Well, only people that are, never mind. So board members of the forum are elected to a term of 2 years by vote of the current paid members, okay? Board members may serve 2-year terms with a maximum of 3 consecutive 2-year terms. How much is that? It's on there. The answer is right there. 6 consecutive 6 consecutive years, okay? So each time they end their 2-year term, they have to be reelected or not reelected, as you know, the course may be. And you can serve up to 6 years in a row, and then you have to take a year's break. Okay. So today's elections for the board members will serve for 2 years from January 1, 2025 to December 31st of 2026. Okay. And at our January board meeting of the new board of directors, we will elect the officers, the president, vice president, secretary, and treasurer. That will occur in January of 2025. And I'll send out an email to everyone to let them know who has been elected as officers and who has been, well, I think tonight we'll be able to tell you who the new board members will be. Any questions? Simple math. John Singleton stepped down because he wasn't able to attend. Okay, these are the folks that are up for election now. Is there anyone who hasn't voted that needs a ballot? Okay. All right. So we have 3 folks that are currently on the board that are up for re-election, and that's Chick Keller, Bob Ranowski, and Kirk Weisbrod. Okay. And we have 6 people that are up for new board members. Okay, so while Chick is giving his presentation, we'll count the ballots and we'll let you know how that turns out. Sound like a deal? All right, good. I get to get off this microphone and have some hot tea. Okay, you're on, Reese.
Good evening, everybody. I'd like to mention Ted Fye, who's a co-author on all this. Ted has spent a whole lot of time looking up things, explaining things, and whenever I don't understand anything, he explains it to me, and sometimes I understand his explanations. Ted can't be here today because he's not feeling well, but, oh, he's here. Oh, there he is. Ted is here even though he's not feeling well. In the question and answer period, there'll be some times when I might not be able to answer the question, and we'll point at Ted and get him to do that. And now we figure out what to push. Oh, okay. I thought I'd put this in. Supposing we didn't know about the universe and how it started and everything else, and someone wrote a science fiction story, no one would believe it. They would say it's too outlandish, there's too many crazy things going on. Big bang from nothing, inflation where everything gets enormous in incidents, electrons flying around, cosmic microwave boundary in the same direction. The galaxies aren't expanding, space is expanding. Get your arms around that. First it was fast, and then it's slow, and then it's speeded up again. Galactic light is bent by gravity. Dark matter makes up 1/4 of the universe, and dark energy about 3/4. So there's hardly anything left of all those galaxies you see. They only make up a small part. I really like this picture. I was not able to get it in focus, but at any rate, it was made in the 1700s. And it's a good idea of what we've been doing. We're living in a nice world with stars and trees and what have you. But then we started looking outside of that, and we were finding all kinds of amazing things. Well, he showed me where to push, but when I pushed, I did. Pardon? It looked pretty obvious to me at the time. Where are you? He went away.
He went away. There you go. He'll be back. Oh, there it is.
So I push shift.
No. Yeah.
I pushed that. It says end. I can't get it to go backwards. Oh, okay. I want to just put this in so that we have a little humility. The J.B.S. Haldane's famous remark, the universe may not only be stranger than we think, it may be stranger than we can think. First, we'll start with Einstein's relativity equations. The picture is of a really remarkable priest, George Lemaitre. Several theoreticians using those equations started figuring out what the universe must be like. Lemaitre was the first one to suggest that the whole thing started with a quote-unquote Big Bang. And he thought that the universe could be expanding even before Hubble with his telescope observed this. Keep in mind, back then, that was remarkable because everybody thought the galaxy was just one galaxy and not going anywhere. But distances, I love this picture of Henrietta Leavitt. She's one of my great heroes because I worked on Cepheids. She got this job of looking at the Magellanic Clouds, lots and lots of photographs around 1900 of the Magellanic Clouds. Now, they're clouds of stars sitting outside our galaxy, and they're far enough away that their thickness doesn't matter. So the brightness variation you see, so when you look at stars now, you can't tell if they're brighter or if they're just closer. But since these are all essentially at the same distance, the brightness variation you see is real. And she noticed one thing. These are variable stars. They get brighter and fainter over a period of days. And she noticed that the longer it took them to go from brighter to fainter, the brighter they were. And she came up with the period luminosity diagram. Thus, if you looked at some distant galaxy and saw one of these stars varying like a Cepheid does, you knew immediately how far away it was because you knew its absolute brightness and then you could see its apparent brightness. And so all of a sudden, the universe got really big. Velocities of galaxies. You've all heard a train come by and loud noise, and as it goes by, it gets lower frequency, the Doppler effect, and that happens with light too. So if a galaxy is moving along away from us, the wavelength of the light in the spectrum that we look at will move to a redder distance. It's called the redshift. And you can calibrate that so you can tell how fast it's moving away. So Hubble had then distances and velocities for the galaxies he was observing. He was the first person to suggest that these things were all outside of our galaxy. Using the distance, Levitt's distance in the velocities, he came up with a very interesting situation. The farther away a galaxy was, the faster it was moving away from us. Lemaitre's equations had actually predicted this. Einstein had a preconceived notion that we lived in a universe that was spherical and not expanding. He argued with Lemaitre, and he had to rethink all this when Hubble showed that Lemaitre was correct. In short, Hubble showed us a totally radically new universe in galaxies were not moving apart, rather space was expanding. We knew this, what we knew before the Webb telescope. This is a picture taken by the Hubble. And I want you, you have a job to do here. I want you to find the one star in this picture. Everything else is a galaxy. All of those little dots of lights are great big galaxies at enormous distances. And only the one that has little diffraction spikes, for those other people who know what a diffraction spike is, but who has those little spikes sticking out, that's the star. Oh, wait. Yeah. Our understanding of the beginnings of the universe is a little different. Fred Hoyle derisively called it the Big Bang. He didn't like that idea, but the term stuck. And the early universe developed in several phases. First, we have really good evidence that it started from quote unquote a Big Bang. And almost immediately, space expanded to huge distances, such that if you looked back, you couldn't see where it started because everything looked the same in all directions. That's called inflation. It was very hot, and it was filled with, finally, it cooled down enough to at least have electrons floating around, but they scattered the light, so when you try to look with a telescope through that at time, you can't see anything. It's all a cloudy mess. The first thing we observed was an afterglow, and it was shifted way over into the, well, because it was cool, also into the infrared and on into radio waves and microwaves. And we call it the cosmic microwave background. After that, the electrons were all captured and there was nothing causing any light. And so there was a dark time. That was after the glow. And then finally, the matter began to condense into stars and made light, and that's the universe we have now. Where did the universe come from? Several pieces of evidence seemed to give evidence that it was a point source, really hot and dense. And Lemaitre's papers had predicted this from relativity. And here's cosmic inflation. The universe just exploded in size. The space exploded inside. And so all the material in it found itself at great distances from each other. Some people think it's a kludge, but to just explain what we don't understand, thank you, Mr. Haldane. But most of the good work suggests it really did happen. One way to prove inflation would be to see gravitational waves from inflation. Now, we've seen gravitational waves from before inflation and after it from a lot of things, but we have yet to detect gravitational waves from the cosmic microwave background. But they keep looking. They would be very faint, and we may find them. Universe cooled down. And about 400,000 years, we have what's called the recombination. That's when all the electrons got picked up by the protons, which were mostly hydrogen. And so we got a period when, as I said before, when there wasn't much life. But the only thing that we could see looking back that far was the cosmic microwave background. If you start with something that is infinitely hot and dense, you just have stuff. And as it cools down, it turns out that many of those things, due to quarks and what have you, will produce protons and electrons. So here's the cosmic microwave background. We were trying to see it from the surface of the Earth. Penzias and Wilson saw it with their radio telescope, and they thought it was static, and they were trying to get rid of it. They thought it was birds, and they kept cleaning off their antennas and that, but they finally decided it was really real. Make a long story short, going into space where you can really see the microwaves with increasingly accurate satellites, we finally got to the Planck satellite, and it had great high resolution. And when you look at this picture of the orange and blue, you're looking at variations in that background, but they are very, very, very small. And so this picture has been amplified a whole lot so that you can see the variations. But we think that it's those small variations that ultimately allow the galaxies and things to form. The dark ages followed after that. Neutral hydrogen doesn't give off light, and so the universe was essentially dark. So if you look at it as a picture, you have the time equals 0, Big Bang, and then the universe gets huge, and you can't see the universe show that, so it just shows it getting slightly bigger there. And that's inflation. And so finally, you get the afterglow, and that was the cosmic microwave background, and followed by the dark ages, and then finally stars begin to form. And as you can see what's going on there, the universe was actually slowing down. It wasn't going to grow anymore. But then later on, it was determined that no, it's speeding up again. Here's Helen Rubin. There's a big telescope. It's going into space in the next few years. It's going to do a whole lot of good, a name for her. She was looking at the speeds of things in a galaxy. And what happens if you have a central gravitational mass and things going around it, the farther away you are from it, the slower they go around. And even though they have to travel large distances, they actually go slower.
when she began to look at the speeds of the stars in the galaxy as you got farther and farther from that dense central bunch, she found that they weren't slowing down. They kept going about the same speed. And it's been called dark matter, makes 25% of the universe, and nobody knows what it is. Lots and lots of ideas, lots of observational things, but you're going to have to stay tuned. The next astonishing finding was 2 teams of astrophysicists began to look at all the speeds of recession of hundreds and hundreds and hundreds of galaxies. And they were trying to get the best estimate of how fast the universe expansion was slowing down. And when Reese first found it out, there's a lot of really interesting emails between him and the rest of the team cautioning, don't say that. You can't say it's speeding up again. And they worked on it. Finally, they got the hold of the other team. The other team wasn't saying anything because they were scared to say something too. And they said, you found the same thing? Yeah. And so there's a bunch of them got a Nobel Prize for it. Reese said, we knew we had it right because we got the Nobel Prize. If you get the Nobel Prize, you must have had it right. And they call that dark energy, and there's a lot more. It's a negative force which actually pushes on space and makes space expand. Here's an interesting picture, and I put up here, it has these letters which tell you who was making the observations when. The Sloan Digital Sky Survey, the Supernova Legacy Survey, that's what Reese and those people were doing. And finally, the Hubble telescope, and then not shown on this graph, the Webb Space Telescope is corroborating this. And this isn't a straight line. It's actually curving upwards, which means after about halfway through all of this, the universe started speeding up.
What is
Z is the term used for the Doppler shift. And the Doppler shift can then be converted to kilometers per second or megaparsecs per second, how fast it is. So that's how fast it's moving. And I didn't want to go into what the other thing is, but it shows quite clearly that the universe is speeding up. So the Webb telescope, very complex, expensive instrument. It was designed to look only in infrared wavelengths. The reason for that is when you look at galaxies, they look really beautiful. One of the reasons is there's a whole bunch of luminous dust and you can't see through it. So you can't see what a lot of the stars are and what other things are going on. But if you look way far in the infrared, you can see through it. So when you look with the Webb, you get a very different look at what a galaxy looks like as opposed to when you photograph it with ordinary light. The Webb telescope, as you can see there, seems to be sitting on a very funny looking platform. They're looking so far in the infrared, they don't dare have the signal even infected by moonlight or by earthshine. And so it's sitting 1 million miles away, floating in a part of space that where gravity between the sun and the earth is about the same. So it doesn't go anywhere, it just goes along in that place. And that thing you see that it's sitting on are multiple layers of shields that keep any light from the earth or the moon from coming to it. It's sitting as close to absolute zero as you can get. So it can make those very, very far infrared observations. Yeah. Oh, yes. Yeah. Who'd you vote for? We're not sure what funding is going to be available for future things. The Helen Rubin telescope will go up, but the follow-on for the Webb is, as they say, probably just on the drawing boards. But it's a good question. If you look at these two pictures, the top one comes from the Hubble, and it's the very famous pillars of creation that shows these long streaming dust lanes and what have you. But if you look in the very, very far infrared, you see through all that, and suddenly all that light on either side of it and behind it and everything else vanishes, and you get a much clearer picture of the luminous material that's there. So this is just to show you what the Webb sees as opposed to what the telescope like the Hubble sees. Also, for those of you who don't know, Einstein's equations predict that if light is traveling past a very massive object, it will get bent toward the massive object. If light comes from behind the sun, a star which you wouldn't see, suddenly you can see because the light has been bent into your line of sight. And that was proved years and years ago during a total eclipse of the sun. But we see it all the time. If you look at the picture here on the right, you can see that there's a big, massive set of galaxies in the center, and galaxies or supernova, for that matter, from behind it get bent such that they give you those curved looks. So when you're looking at a lot of these pictures of the Hubble and of the Webb, if you see strange looking things like that, that's relativity. It allows you to see things that are even farther away than you could because the light gets concentrated. Okay, so the Webb telescope can see back in time. Here he says the first galaxies and black holes forming should be pretty small. They're just getting started. That isn't what the Webb shows. They're very large, and there's you can talk to 52 different astrophysicists, and they'll give you 52 reasons why that should be the case. But the one thing that the Webb did was it was able to look at how fast these objects were moving away from us, and it confirmed what's called the how did I do that? Yeah. Oh, thank you. The Hubble tension, I didn't want to go into that, was in enough time. But if you look at the rate that these things will be going away from us, and you calculate it from supernova and from galaxies and this and that, you get one number. If you look at it at the very first time we could see things, the cosmic background, microwave background, we get a different number. And people have a lot of trouble with that, and they're still trying to figure it out. And they thought the Webb would solve that problem, and it didn't. It backed up the one that you see from supernova. So the Big Bang and God, proof that the universe had a beginning has caused many religious people to say that this matches Scripture and proves God created the world. I'm right now busy reading a very technical, not very technical, but somewhat technical book in which it shows that if this is the only universe we have, you cannot get around the fact that there was an intelligence that designed it. And we could talk about that for a long time over a beer, but that's what people say. Yeah, how many beers? You just keep it up, yeah. And one of the reasons is that when you look at all these different constants that make the atomic physics go, that make the light go, and what have you, you look at all those different things, how strong gravity is compared to the strong force in the atoms and this and that. If you changed any one of those by a little bit, we wouldn't have the universe we have. We wouldn't have living people. And it's called the Anthropocene principle. it seems to be strong evidence for a creator who designed it. To get around this, people who quote in the back of their head, no, there can't be a creator, a God, they've come up with the idea of the multi-universe theory. If you have an infinite number of universes, one of them is bound to look like ours, and we just happen to be in it. That's an idea that rhetorically you can argue, but there's no way to prove it, and it seems relatively strange. Perhaps not a correct assumption. The Lemaitre himself, Catholic priest, didn't want to say that what he had found with his equations proved that God existed. But Pius XII, who he talked to, took it and ran with it and stood up and said it did. Lemaitre got really upset. He didn't want his predictions to be minimized by saying, oh, he's just a priest, he has to say that. He wanted them to stand on their own. So what do you think? So if we review that complex universe, the Big Bang, immense inflation, universe very hot, slowly cooling, cosmic microwave background, free-floating electrons, dark time, galaxies forming, expanding, slowing down, speeding up, dark matter, dark energy. That's the kinds of things that we're dealing with if we think about this creator. Seeing the extremely old and large complex universe, why would the creator do this if the basic reason is for souls to be tested and to go to an afterlife? I mean, it seems like an awful lot of craziness to go through if that's not what's really going on. If the age of the universe were if the age of the universe were compared to the height of the Eiffel Tower, the time that humans who are dealing with the creator would be the paint on the top of the tower. So he went to all this trouble, and you wonder why on earth he would do it. And so the one takeaway from this talk I'd like to give you is for you to come up with your own idea of why the creator would do this. I have a few ideas. Some people look at Psalm 19, the heavens declare the glory of God, and the skies proclaim the work of his hands. So they say it's just to show off how great he was. Well, if he had just made one galaxy, that would be enough. We would just be totally amazed. He doesn't have to be any greater than that. He doesn't have to make the universe expand and slow down and expand again. So that's not a very good answer. Well, you may have other ideas. There might be another answer, but one that could make us change our idea of the extent of the creator's knowledge. Theologians hold that God knows everything and is outside of time. We can still adhere to this if we note that the creator can't know the future simply because it hasn't happened yet. It doesn't exist. So the creator knows everything that exists, but he can't know the future because it hasn't happened yet. In such a situation, he could, giving all the physics and biological rules and laws and the attractors that would ultimately lead to living beings, the creator could just set it in motion and watch it happen, giving creation itself the same kind of freedom which he gives human beings to become what it will become. And just like our lives are sort of a wandering back and forth and strange, unbelievable things happening, the universe has done the same thing. It doesn't do away with God's purpose. There's all kinds of mathematical things that show even in a complex system, you can have strange attractors, you can have this and that, and it will get what the creator wants. But if you want to think about that, I'm quoting Genesis here, let the land produce vegetation, seed-bearing plants and trees on the land that bear fruit and seed according to their various kinds. He didn't say, I'm creating all these things. He just said, let the land be. There it is in Genesis. Exactly the idea. Give the land the freedom to produce what it can produce and let it go. Similarly, for the universe, the creator could just start things and see where they go, and then watch how a free universe would do it. So the creator brings our world into existence restricted by those things. These rules are sufficient to create very complex organisms. I love the cartoon of this guy in a white robe and a beard, long hair, looking like the creator. And there's an angel standing beside him, and behind him you can see all the stars and galaxies and that. And he's looking very smug. And the angel is saying, "You did it all with quarks? Get out of here." But that's exactly what he did. Why would the creator do this? Perhaps the creator wanted to give creation a certain freedom. So does God's love result in freedom to become? If so, starting the universe with lots of energy would have then proceeded according to the creator, and the resulting development is what you would see. Another idea, by actual count, there are billions of galaxies. Each galaxy has billions of stars, and they probably all have planets. The implications of such numbers seems to make theologians modify their ideas of salvation, where the creator enters each civilization. So in the talk I gave earlier this year, you're stuck with the fact that there must be billions of civilizations working out their lives according to the rules the creator has given them, and trying to become the best they can, but making mistakes and everything else in very different ways. And so another idea would be, one of the reasons to let the universe develop as it did is to have all these different galaxies, so that we could have all these different beings interacting with God. God, in his great love, wants to share with many, and so makes the universe that have produced that. Other ideas, questions? Thank you.
So one of the compelling aspects of this material that you've presented so well is that there is such a tremendous range of dimensionality. The difference between the size of the perceived universe, which we do not know, is the limit of what it is. So the universe keeps getting bigger, the better we're able to look. The difference between that and the smallest living thing, or the smallest particle, is astounding. Likewise, the difference in magnitude of the forces that are available to us, the difference between the strong force and the gravitational force, I've heard it compared to the difference between the size of the universe and a centimeter. That's an enormous difference in magnitude of something that both of which affect our lives in such dramatic ways. Do you have any thoughts about why do we need such a big sandbox? Why not just pack things in? Is it necessary for there to be such large scales in order for this stuff to exist?
Well, I think that's exactly the question we're asking ourselves. Why would the universe go to the trouble to do that? He did it all with quarks. Everything you see came from quarks. And so you have an enormous universe. It's enormously old, but it came from enormously small things. And the forces
that are involved between gravity and the strong force which keeps the protons all together in a nucleus. That's what you get when you give this thing
Here's the microphone.
this creation. When you give this creation the ability to do it.
You said everything we see comes from quarks.
Yeah,
Everything we don't see, what does it come from? I'm talking about dark matter.
good question. Stay tuned. Ted, do you want to comment?
Yes, well, of course, that's a function of our measuring instruments, right? We went for a long time where we didn't see the cosmic microwave background. George Gamow here, when he was here at Los Alamos, was working out the temperature, which gives us also the density, the number of particles in the cosmic microwave background. They're light particles. There's a billion of them for every cubic meter of space. A billion. The number of, on the average, the number of protons on the average in space is 1, relatively speaking. The number of electrons, 1. What the dark matter and the dark energy is, we don't know. Every attempt to detect them as particles has so far failed. Of course, there are lots of candidates. There may be axions, for those of you who know what that is. There's been a lot of particles that have been proposed to be the dark matter. Every time we look, we come up with nothing. Maybe we just don't know how to measure them yet. I hope that helps a little bit.
Just let me briefly remember the alpha, beta, gamma paper, which was formative in my understanding of the universe. And second, an old friend, Alexander Rimsky-Korsakov, that from the Klopin Radium Institute, that was so focused on understanding dark matter. It would do cartoons, and I love them, about this, thought experiments.
Make sure you tell them who beta.
Beta, I think, wasn't he the student? Hans Beta, wasn't he the student of Gamma?
Now, Hans Beta was actually the student of this guy in Germany, Sommerfeld. Anybody remember Sommerfeld? Some of you won't remember. But he was an astronomer, a physicist at the turn of the century, very famous. And he wanted Beta to stay in Germany. But the time was around 1930. And Beta was Jewish. And he wisely decided to leave Germany.
So what was your question?
I think it was a comment. We can save the rest of the questions and comments for Chick following the rest of the presentation.
I'll have to tell you that all these incredible theorists and what have you have senses of humor. The fellow by the name of Alpher was working with Gamov, and they came up with these ideas, and they decided that they should get Beta to be on the paper, so it would be alpha, beta, gamma.
Very good. Can you tune it up?
Uh, the ideas of neutron stars, if we took our sun and collapsed it down to a neutron star, it would fit between here and Santa Fe. In 1966, when I was in graduate school, I was taking a course on stellar interiors. And my term paper that I had to write for it was to argue whether or not neutron stars could exist. That was 1966. Now, nothing. Any other questions, quick? Yes, all the way in the back. No, that's time going from left to right. Is that, I'm glad you asked that. It's a little confusing. Yeah. I don't know a lot about Helen Rubin telescope. It's going to be very large. It'll be something like the Hubble, but it will have incredible electronics on it so that it can survey, millions of galaxies and do all kinds of things. But if you want to read about it, just write Helen Rubin telescope in the web and you'll see it. Yeah, Ted. Here, use this.
We called her Vera Rubin.
Vera,
And her telescope is actually ground-based. So it's one of the largest telescopes, but it has this extremely expensive detector, which has millions and millions of pixels. So it's looking at it has a very wide field of view. So it's looking at 1,000 times as many stars and galaxies at one time. And the data will just be pouring in that all the astronomers in the world won't be able to look at it. They'll need artificial intelligence and computers to look at the data that's pouring in. A similar instrument will supersede, because somebody asked that question, I think it was Dan, there will be another space telescope. It's called the Nancy Roman Space Telescope. It probably is going to fly. It's not much bigger, but like the Vera Rubin telescope, it has this enormous field of view. So the data is going to pour in at maybe 10 to 100 times the rate of the current instruments. I hope people understand that. A lot more pixels, a lot bigger antenna to send the data back to Earth. So astronomers will have plenty of stuff to look at. In fact, they'll have to probably engage most of the students to try to look at the stuff because the data will just be pouring in. I hope that answers Dan's question. Excuse me? Oh, the Vera Rubin telescope should go online sometime next year. The Nancy Roman telescope, well, that depends on Donald Trump, I guess. I'm sorry to have to say that, but I don't want to get into politics, but I think if Biden had or Kamala had continued to be president, then it would have probably been launched in the very near future, certainly within the next couple of years. Of course, it's more expensive. Yes.
Okay, I'm going to intercede.
Maybe Elon Musk launch.
We're not going to have a political discussion, Ted and Gary. Thank you very much for your thoughts. We can do that later. And can we all thank Chick for his marvelous presentation and his willingness to answer some questions? You guys are great. Thank you very much. And you'll hang around for a little while for people to do. And could I ask Bob Winowski, do you have the results of our election? Well, he's coming down. Let me encourage everyone to send me an email, if you don't mind, sprakesusan@gmail.com. And yes, he has a clearance. He also has, make it even worse, he also has a wife that helped him count. Oh my gosh, okay. Anyway, send your thoughts and comments to me regarding our upcoming 2025 summer lecture series. So that's sprakesusan@gmail.com. Okay, let's see if I can read this. I owe you how much money? Oh, sorry. Oh, we were going to talk about that. Okay, so it's for 7 people, right? So that would be Rabbi Jack Schlachter. Please stand up. Yes, you. Father Colin Kelly is going to be on the board for the 2025-2026. Joyce Gusick, where are you at, Joyce? Did she leave already? Okay. No, I thought she was here. Okay. Damon Giovanelli. Hey, hey, hey. Yay. Kirk Weisbrod was reelected. Bob Ranowski was reelected. You didn't get very many points there. And Chick Keller was reelected. Okay, so that will be our new board for 2025-2026. And again, let me encourage you all. Thank you all very much for being here. This is my last term as president of the organization. You can only hold an office for 3 years, so it's been an honor for me to work with all of you, and it's been a great pleasure getting to know you and getting to find out all these wonderful different speakers that we've brought in. So thank you all very much. I appreciate it. And the elections with the board in January will elect the new directors for the upcoming years. Okay? Thank you. Oh, thank you, Chick. I paid him for that, Thank you all. And please help yourself to whatever's left of the pizza and hang around and chat with folks. Thanks much.